Hello, we're going to be looking at problem number 1 on page 571 of your geometry textbook. This is in lesson 9-4. Before we do, though, I want to bring your attention to the rule up here that says a composition of reflections across two parallel lines is really nothing more than a translation, or what we call a slide. So if you reflect this from here to here, and then you reflect it again over another parallel line, if you'll notice the first and the last, it's as though you just took that and you slid it straight down. So that's what they're trying to say here in this particular one. So problem number 1 says, when you see this right here, it means to take the reflection of J over line L first. Then once we do that, then we're going to reflect it over line M. That's the way you have to do this. The one closest is the one you do first, and then reflect it over M. So we're going to reflect it over L first, then we're going to reflect it over M secondly. Okay? And so here's the two lines that they're saying, and here's your J. Now they've just redone that right down here as they give you the answer. As you do two reflections, please keep track of the distance moved by the point P to the pre-image. The pre-image is what the image was original. So its pre-image is what your original image is, which is the J right here. Now, we're just taking one particular point. There's really a bunch that would make up the letter J. We're taking one particular point. If we reflect that across line L first, remember a reflection has to be perpendicular to the line of reflection and the same distance away. So from P to A would be the same distance from A to P prime right here. And also, again, it would be flipped, so that's why this J looks like this after it's been reflected. Okay. Then, so that means this distance right here there's one, and that's the same distance, so it's 2AP. That's where they're getting this right here. Okay, or 2AP prime, same thing. Now, if we reflect it again, over this, again, it's got to be perpendicular to this line, and it's got to be the same distance across there from where that point was on there to where it is across the line in the reflection. Okay? That is the same distance there. So again, that equals that. Well, that was the same distance from that line as that is from that line. So if you really think about it, that's considered the distance between A and B. That would be half the distance from A to B, and that would be half the distance from A to B. So the total distance that this actually gets translated or slid is 2AB, which is 2 times the distance between the two parallel lines. Okay? There's a half, which makes a whole, and of course there's a half, and there's a half that makes a whole AB right there. Okay? So that's why they're saying that the total distance moved is twice the distance between the two parallel lines, which is being called AB here. All right? Now, if you'll notice, once it gets reflected again, it's just as though you slid that a distance of 2AB over here. Because two reflection, or a double reflection, they call it a composition of reflections, which just means two reflections back to back. Ends up being just one big translation or slide. Now, in the got it section, it said draw parallel lines L and M as in problem number 1. Draw J between L and M. What is the image of if it got reflected across the L axis first and then across the M line? If we reflect it, then what would be the distance of that? Now, this looks a little tricky here. Maybe I can draw it here. If I drew a J in between that, well, let's just ignore that one. The original one here is right here. So if we reflect over the L axis first, which is what this is telling us to do down here, we're going to reflect over L first, then it becomes this J that we see right here. Okay? Then if we reflect that over the M, remember it's got to be perpendicular. If I take that same point, it's got to be perpendicular to line M, but the same distance. So from here to here, it's got to be from here to way over here. That J would be this way if it got reflected. And then if it gets reflected again, it's going to go back to looking like the original J. Now, the distance, again, this right here, what is the total distance resulting in the translation? If it were here and it got reflected here, that is half the distance between L and M. Okay? And then if it got reflected all the way back over here from the original one to here, this is a half, this is a half, this is a half. Okay? And so if it got reflected all the way over here, this is going to be 1.5 over here, because this right here, which is 3 halves, is going to be the same distance here, which is 1.5. Okay. So you already had a half, which is this part right here, and then 1.5 here, so that's going to make a total of 2 distances. Now we can call that AB again. You want to refer to that as A and that is B, but it's really twice the distance between L and M. That's the way we have to think of it. Okay. Hope this was helpful. And if we look at the reasoning, it says use the results in Part A in Problem 1, make a conjecture about the distance of any translations that is the result of the composition of reflection across 2 parallel lines. Well, as you can see, anytime it gets reflected across 2 parallel lines, the distance is always going to be twice the distance between the 2 parallel lines. Because if you see in both examples that we worked, that's the way it ended up being. All right?